In this video, I will explain the difference between two direct types of stress, normal stress and shear stress. Previously, we know that stress is force per unit area. It is internal resistive force per unit area. If we know that what is the angle of the force with this area, we can predict either it is a normal stress or shear stress. Sometimes it is tricky, but a simple difference is if we are applying force on a member, two equal and opposite forces are important or must to produce stress. If force is being applied perpendicular to an area, it will produce normal stress. This force can be acting towards the area or away from the area, like in this case. If force is acting towards the area, it is a compressive stress. It will try to reduce its length in the direction of the force. If it is acting away from the area, it will try to elongate the body, and we call it a tensile stress. So both the compressive and tensile stresses are types of normal stresses because in both the cases force is perpendicular to the area upon which it has been applied. In other case, if force is applied parallel to an area, again two equal and opposite forces have been applied parallel to an area like this. Both these forces are trying to change the shape of the body. For example, initially it was a rectangle, now it will be a rhomboid. So we can see neither we have increased the length or decreased the length, simply the angle between the adjacent sides have changed. Initially angle between each side was 90 degree and now it has either decreased by a factor gamma or increased by a factor gamma. Gamma is shear strain. So in case of shear stress, the force will be applied parallel to an area. In case of normal stress, the force will be applied perpendicular to the area. In normal stresses, the body will either, under normal stress, the body will either elongate or compress. The length will either increase or decrease. In case of shear stress, the length will neither increase or decrease. The change in shape will be in terms of change in angle. So there will be a shear strain, and shear strain is the unit of shear strain is radian. The unit of normal strain, there is no unit of normal strain because normal strain is change in length per unit original length. Okay, but again there is a confusion. For example, if we have a body and there are two equal and opposite forces applied on it, the forces are looking like perpendicular to some surfaces like this, but these two forces will neither elongate nor compress the member. We can see the forces are not in the same line of action, there is an offset between them, and the body will break like this in two pieces. So if we take one of the sides, there is an applied force. In this free body diagram, we have to apply a reaction force on the fractured surface, on the fractured area. So it must be opposite to the applied force so that summation of forces are zero. And this reaction force, which is internal force actually, it is parallel to the area upon which it has been applied. So it is producing a shear stress. Initially, two forces were looking like perpendicular to some areas, but the effect is a shear strain or a shear failure. So we have to see what is the angle of the internal force with the internal area. Similarly, in case of tensile or compressive force, which we call normal stress, they are trying to elongate a body, and if this body breaks in two pieces like this, and I'm taking one of the sides like this one, there will be a reaction force on the fractured surface or the broken surface which will be equal to the action force, and it is perpendicular to the area. So this internal force is perpendicular to the internal area and it is producing a normal effect. So it is producing a normal stress. So what we have to see that what kind of failure is intended. Either the body will fail due to tension, due to compression, or due to shear. So that internal force per unit area is actually the effect of the force, and if that effect is normal, so we have to call it a normal stress. If the effect is shear, so we have to call it a shear stress. But simple definition is if the applied force is perpendicular to an area, either tensile or compressive, so we call it a normal stress. If the applied force is parallel to an area, it is changing the angle between the adjacent sides, we call it shear stress. So I hope this concept is clear. If there is anything, we can discuss again. Thank you.